Welcome to G Fun Facts Online, where we dig deep into the fascinating corners of our world and sometimes even into the distant past. Today, we're not just digging for treasure, we're unearthing silent stories, stories etched into bones and whispered from ancient burial sites. We're talking about how archaeology reveals the devastating health crises that shaped civilizations long gone. It's a journey that's part detective story, part history lesson, and incredibly relevant to our understanding of disease and human resilience today. So how do archaeologists become disease detectives of the past? They have a pretty impressive toolkit. First up, there's paleopathology. That's a fancy word for the study of diseases in ancient remains. Bones are a key witness. While they don't spill the beans on every illness, some diseases, like tuberculosis, leprosy, and syphilis, leave very distinct, almost signature-like lesions. But often the signs are more general, telling us someone was sick, but not the exact culprit. Think of it like a check engine light for the ancient human body. Then there are burial patterns. Imagine finding a sudden spike in burials, or mass graves, or bodies buried in layers, sometimes with lime, which was an old-school disinfectant. These are red flags for a major catastrophe, like an epidemic, especially if there's no sign of a big battle. Archaeologists also examine entire settlements, how people lived, their water supply, sanitation. These give clues about conditions that might have let diseases run rampant. But the real game changer? Ancient DNA analysis, or aDNA. Scientists can now pull the genetic material of actual bacteria and viruses from teeth, bones, even mummified bits. This is huge. They've identified Yersinia pestis, the plague bacterium, in dental pulp from victims of past pandemics. And they've traced viruses like hepatitis B and smallpox back in time too. And there's more. Histology lets them look at cellular structures under a microscope. Coprolite analysis, that's ancient poop folks, reveals intestinal parasites. Even soil from graves can tell tales of parasites. And chemical analysis of bones can give insights into diet and movement, all relevant to how diseases spread. All right, with these tools, let's look at some chilling case studies archaeology has brought to light. Think way back, around 3000 BCE. In China, a 5,000-year-old house was found filled with skeletons, a prehistoric epidemic frozen in time. Around the same time, Yersinia pestis * DNA, the plague bug, was found in a Stone Age skeleton. And stone as Salmonella enterica, a nasty precursor to enteric fever, was found in Bronze Age remains from multiple simultaneous burials in China. Epidemics aren't new, not by a long shot. Fast forward to the plague of Athens in 430 BCE. Thucydides wrote about its horrors. Archaeology backs him up with mass graves and disrupted burials. This plague didn't just kill people. It weakened Athens, contributing to its defeat in the Peloponnesian War. Then there's the Antonine Plague, around 165 CE, likely smallpox, carried back by Roman soldiers. It killed millions and helped end the Pax Romana, that long period of Roman peace. The Plague of Cyprian, mid-3rd century CE, Saint Cyprian described it as apocalyptic. In Luxor, Egypt, archaeologists found a mass burial site, bodies covered in lime, likely from this devastating outbreak. The Justinianic Plague, starting in 541 CE. This was the first Ames-confirmed manic pandemic of Yersinia pestis. It tore through the Byzantine Empire, killing about a quarter of the Roman world's population and derailing Emperor Justinian's grand plans. DNA evidence from Britain to Spain shows how widespread and diverse the plague strains were. And of course, the Black Death, mid-14th century. The most infamous one. Again, Yersinia pestis. It wiped out roughly a third of the world's population. Archaeologists see its mark in mass graves, like those in London, where bodies were piled up in haste. Jumping across the Atlantic, the Cocolitzli epidemic in Mexico in the 1540s. After Europeans arrived, new diseases decimated indigenous populations. aDNA from a cemetery identified Salmonella enterica paratyphicae as a likely culprit brought by Europeans, and smallpox in the Americas from the 16th century on. It was catastrophic for Native Americans with no immunity. Recently, in Peru, 500-year-old Inca children's skeletons showed bone changes characteristic of smallpox, some of the earliest evidence in South America. These epidemics weren't just about people getting sick and dying. They sent massive ripples through societies. First, demographic collapse. Huge population losses changed everything. Social structures, who was available to work. This led to economic disruption, lost workforce, broken trade routes, abandoned farms. The Black Death, for example, helped bring down the feudal system in Britain. Politically and militarily, empires weakened. Think Athens or Justinian's ambitions. Even Viking exploration of North America fizzled out as plague hit their populations in Greenland. And social and cultural transformation. Imagine the fear. Sometimes, social order broke down, religious beliefs shifted. The spread of Christianity was, some argue, spurred by the apocalyptic feel of these times. Burial customs changed dramatically, with mass graves becoming a grim necessity. Human movement was key. Trade, war, migration. These all spread diseases to new, vulnerable groups. The story of European diseases in the Americas is a stark reminder. Now, peering into the past like this isn't easy. Archaeologists face some serious hurdles. Preservation is a big one. Soft tissues, where many diseases show up, rarely last. Even bones can degrade, losing evidence. Diagnostic limitations. Not all diseases mark bones, and when they do, the signs can be vague. Plus, diseases that kill quickly might not leave any skeletal trace at all. Contamination is a constant threat, especially for aDNA. Modern DNA can sneak in and mess up the results. Context is everything. A diseased bone tells a better story if you know about the burial, the site, the artifacts. Without that full picture, it's harder to be sure. And pathogens evolve. Ancient strains might be different from today's versions, making identification tricky. So why does all this ancient gloom and doom matter today? The lessons are incredibly relevant. First, understanding disease evolution. Tracing pathogens like plague or salmonella over millennia helps us understand how they change and spread. This is vital for tackling current and future threats. It highlights human-environment interactions. Shifts like farming, city living, and global trade created new opportunities for pathogens. This teaches us how our actions today can impact disease emergence. We learn about societal responses to crisis. History shows us a whole range, from collapse to incredible resilience, and even the beginnings of public health, like quarantine. This can inform our own pandemic plans. We see the deep history of zoonotic diseases, those that jump from animals to humans. Archaeology shows this isn't a new problem and underscores the link between human and animal health. And it reveals vulnerability and inequality. Often, diseases hit certain groups harder. This link between social inequality, stress, and health is, sadly, still with us today. The study of ancient epidemics through archaeology is a field that's constantly advancing, especially with new DNA techniques. By unearthing these stories, we're not just learning about the past, we're gaining critical knowledge to face our own health challenges. It turns out, the silent testimony of bones has so much to teach us, the living. That's all for this episode of Fun Facts Online. Join us next time as we uncover more amazing facts from around and beneath our world. Thanks for listening.